This video is to show you how to do problem number 2 on energy conservation with a rotation word problem. And again, this one, just like problem number 1, doesn't really have anything to do with energy conservation. It's trying to help you get used to the idea of angular rotation as opposed to linear velocity. So every linear variable that we've learned, distance or velocity or acceleration, has a corresponding angular, and the relationship is always, if you look up here, it's always that your linear equals the radius times your angular, and we always use Greek letters for angular. So the distance, if I'm talking about how far around I'm going, that's my angle, and our angles will always be in radians. This is the one time in this physics class you have to use radians, and I won't play any games with you. I won't give you degrees and make you change them to radians. Okay? My velocity is equal to the radius times, again, the Greek letter omega. We use that for how fast we're spinning, and we'll do a lab with that later. And my acceleration is r times alpha. Later on we'll use these equations. We won't need those for this worksheet. So they want the linear velocity. That means they want my v, and they give me my angular velocity, which is my omega, and they give me my radius. So again, this is just a really simple problem once you know what the letters mean. So my velocity equals my radius times my angular velocity. So that's 0.35, and again I gave it in radians per second, so I don't have to change anything. And I multiply those together, and I get 15.8. And that's meters per second. The radians just go away. Radians are considered a unitless, it's a unitless unit. I don't know how much sense that makes, but when you multiply this, you're going to get meters per second. The radians you don't have to worry about canceling. It's all part of the formula. And that's how you do problem number 2.